Welcome everyone to another live stream event by Nanome. Today, we'll dive into PROTACs with mixed reality, analyzing protein interfaces and positions utilizing the data table plugin. Designed for scientists working with multi-frame data, this plugin is set to help the decision-making progress every time you are dealing with structures and data in Nanome. During this live stream, Nanome experts Jonathon Gast, Steve McCloskey, and Martina Maritan will showcase the data table plugin and demonstrate how to effectively use it when iterating on docking poses and exploring protein surfaces. Those of you who joined us last time might remember our Nanome experts, John, Martina, and Steve. Their full bios are available in our previous episode and in the description, so feel free to check it out. Just like in our previous streams, we'll be using the MetaQuest Pro mixed reality device. For more information on the differences between virtual reality, mixed reality, and augmented reality, feel free to pause this stream or view our previous streams as well. And lastly, just like we usually do, we'll have a Q&A section at the end, so feel free to ask questions throughout the stream, and we'll be sure to answer them by the end of the stream. So without further ado, let's dive in.
Okay, fantastic. Thank you, Kata. So yeah, you can see we have Kata here in real life managing the stream. Just as a preface, so I am in mixed reality here. I do have an avatar. You can see that I have an avatar hand. I can turn that off, turn my avatar hand back on. I'm going to use it just so you can see what tools I'm using. And then we have John Gast joining us from Chicago in his avatar form. And then we have Martina in real life over here. Of course, we could show Martina's avatar, which you could see looks very much like her. But because she's here in real life, we're just going to go ahead and hide that and yeah, collaborate locally as well as collaborate virtually. But yeah, Martina, do you want to explain a little bit more about PROTACs and the structures that we have here?
Yeah, of course. Welcome everyone to Nanome. So today we're gonna talk about products and more specifically about we're gonna dive into this ternary complex of SMARCA2, our product, this small molecule right here, and E3 ligase. So just to give a little bit of context about PROTACs and what is the concept behind this uh, particular set of drugs, I will show an image. Here I just pull my web browser, and the concept is really like brilliant, I would say. So PROTACs are these bivalent small molecule that have a site that will target E3 ligase, the E3 ligase, and then another site that is specific for the target protein, which in our case today is our SMARCA2 protein. And the whole concept is trying to hijack the ubiquitin proteasome system. So once this ternary complex is formed, because the product basically connects E3 and the target protein, the E3 ligase induce the ubiquitination of our target protein, which in turn leads to the degradation of our target protein by the proteasome. And so this is a very brilliant system that has been explored for what in the past have been deemed as undruggable targets. So,
Yeah,
uh,
actually, maybe if you could just pull that up real quick, just the web browser that
yeah,
you just had. Yeah, so this is the shared web browser. And what we've done, we just Google search some images here. And yeah, like Martina was just saying, we have our ligand and our target, our ligand and our E3 ligase. And then we just connect them with the linker, and that will get our target deleted by basically the system that's already in place here. So yeah,
yeah.
fantastic. Thank you for that explanation. And of course, yeah, we have the structures. What else were you saying about that?
Yeah. So just to give some vision here, as I was saying, SMARCA2 is gonna be this blue one. The E3 ligase is gonna be here in teal, and the PROTAC is the small molecule right here, and so we can already distinguish the part that binds on SMARCA on the bromodomains and the part of the PROTAC that binds on the E3 ligase and this linger here that brings this ternary complex together. And yeah, and this in this case, this has been studied for against cancer and has shown really good promises. Uh, and yeah, and he's gonna is inhibiting the proliferation of multiple cell lines of cancer. But
Fantastic. Yeah. Thank you, Martina. Yeah, it was a really thorough explanation. I'm just going to go ahead and take presenter here and try to give the audience a little first person view of what we're looking at as well. So we have our E3 ligase in the teal, and then we have the ligand bound in this light blue type of color right here. You can see that it's nicely bound right there in the binding domain. And then over here, we have a PEG linker connected to our other ligand that is in our target protein. In this case, it's the SMARCA protein. So you can see that we have ligand over here, got our ligand over here, and then we got our nice linker, and that's pretty much the PROTAC. So we're going to be going over kind of the concept of how you might want to approach designing new PROTACs based around different hits that you might get on docking results that you might have binding to your target protein. So John, yeah, do you want to explain a little bit more about what you've been working on?
Absolutely. So I'm gonna steal presenter just for a second. So overall, as they kind of been mentioning, we kind of do have like these three sort of areas, and we're gonna look at innovating alongside some Romo domain binders up here, and so we're gonna see what else we can get to bind to Smarker 2 to help bring it in for our ternary complex. And then also we're going to take a look at some other ways we can, you know, kind of vary that. So here with 6HAX, so I can see this in a slightly darker blue and everything there. We're seeing that we have everything is very, very similar, except now what we have is a little bit of a different binder. So I'm going to go back to this frame. And so we can see our bromo domains are identical. But our linkers are different, and our VHL binder is also the same. So we can innovate right here along the link curve, where in one form we have a peg linker that's very flexible, friendly as far as some of our, solubility concerns potentially. But there's some good reason. You guys can check out this paper that we'll have linked. We might want to make it more rigid, reduce the number of rotatable bonds, help encourage, this really great pose that we have here on both sides, and increase affinity overall. And so that's one way of making changes. But the other is we're going to kind of come in here and we'll bring up another binding mode. So here, we'll just kind of go back. And whereas before we had just the linker different, now we can see in green and purple, we have two very different ligands. The green, we have this bromine going deep into the pocket, getting some halogen interactions. It's a little less dependent on, the waters that are complex there that we have in our purple. And so we can both dock new molecules into the bromo domain and then build into a linker and try different designs there. And so overall, since we are able to have a really consistent set of interactions here along VHL, we're going to try to keep this area as fixed as possible just because of the high affinity that this already has with its really key interaction with the hydroxyproline that people have found, a long time ago. Although technically we could make some change to this, increase the affinity for VHL, technically, but here we'll be leaving that alone and really just be looking at different ways to branch and link, and as well as other bromo domain binders. So I'm going to use our new scene viewer. It's really great for this sort of thing of where I have multiple workspaces to kind of cycle through, and we'll just kind of take a closer look at the bromo domain and look at some inhibitors of bromo domains that have already been discovered, and try to see how we might be able to go in here and instead of just using the same ligand as before and trying new things there, I've collected a number of molecules we might want to bring in. So here I have a group of 4 SMARCA2 inhibitors of the bromo domain. So I can kind of cycle through these, we have all of those. But I've also brought in some other inhibitors of different bromo domains, such as BRD4, and we're going to see if those are maybe going to be able to fit in here, and maybe we can try to make a new PROTAC by using a different bromo domain inhibitor as our starting point. And so I have both of these here. I'm going to use this set of SMARCA2 known binders as sort of my positive control to see what I should expect to see and how I think it should bind and everything, and see which poses and which molecules out of the other bromo domain inhibitors I want to use for our new PROTAC idea here. And so to do that, we're going to set up a dock. And so a nice docking experiment using Smina docking and Nanome. We'll just activate and we'll run it. And we can see here on the menu, it's really easy to set up. All I'm going to do is put in my SMARCA2 inhibitors, my other bromo domain inhibitors as the ligands I want to dock. I'll use the bromo domain as my receptor, and I'm going to use the ligand from the co-crystal structure as my docking site. And I can see there in green the area that's going to be searched for different conformations. I like using co-crystal ligands as my docking site in Nanome. It's just a nice, fast way of getting a pretty reasonable grid. Of course, we can customize and do that later, but you can see how easy it was to set up. And let's take a look at some results together. So I'm going to hide these two. And from here, we're going to, instead of going into the advanced menu, which, longtime Nanome users are probably familiar with, we can go into the advanced menu and sort through these one by one, but I've got a lot of poses. I have a lot of data.
You just want to quickly go through maybe all of them
Oh,
on the like 50x speed and just play through it
oh,
just to see
sure.
really
Yeah,
just
let's
how many of
let's
these that we have.
bring in the Smarka 2. We'll bring that into the pocket. So in gray, we have our docking results, and in pink, we have our original ligand. So if I just run through that, even, 50 speed, we can see we just have a ton of molecules to look at. And
Yep.
this is what's really great about the data table is that we now, instead of having just this one by one view, we can go into data table and we'll just activate this. It comes on the web browser, which comes with certain, sort of superpowers, I like to call it, for the data table. Makes it so that it can be shared, using the share URL in case I want to send this to Steve as well. And so Steve can also have his own data table on his web browser as he goes. But I'm just going to come in here, look at my Smarka 2 docking results, these 200, different poses. And I'm going to be able to do a few things here to kind of expedite how I look through this. So the first thing I'm going to do is I could just, order these by minimize affinity, but I like to start off with just a simple graph here of minimized affinity, and I'm going to use molecular weight sort of as my identifier, and I'll just make this full screen. And now I can see a bit of the range for my known SMARCA2 inhibitors. Now they're going to be around -8-ish for how they're binding. And I can look at, some of the better poses just by clicking on them in the graph. And so this one here is of the ligand that we, from the co-crystal structure, and we can see that it, recreates the binding mode pretty much exactly,
Yeah.
which is great to see. But I could also come over here to maybe a slightly different one and click on that and see maybe how this one's fitting in differently. It has a similar, sort of phenol coming off here that's engaging the same way, but has a different group coming out of it and a few other interactions that it uses to fill in the space. So I'm pretty happy seeing where this is at. But, these are known SMARCA2 binders. People have been able to iterate on these with PROTACs before with SMARCA2. Let's look at something a little different. So using that data from there, I'm now going to take a look at my other bromodomain binders. I'm going to hide this one here, and I'll bring in the other molecules. So here we are with our other results. And I'm going to do the same thing as before of where on my, I'm just going to hide the graph here. And we'll just take a look at the same graph, but with our different data set. I'll just reconnect real fast. There we go. So here we've got our 9 molecules, and we can kind of take a look at these. We can see there's some, ones that have a way better score than some of ours. And we can see they have a similar, binding mode, once again, with the phenol deep into the pocket, having similar interactions. But we can also look at a few others. And there's one that I was looking at earlier that I was a really big fan of. And it's this one here that it's just going into the pocket really nicely. It has a very similar pose, lots of similar things. And I'm seeing a nice branch point that's really similar to mine from before. Lots of ways to filters and think. But, we're just trying to look for a few good ideas. We could do both of these, but we're just going to go into build a PROTAC now from this one. And we'll
So yeah, we'll go to the PROTAC building scene. So yeah, we have our docked results. Now based on the docked results, how do we actually make that into PROTAC? So we're going to be building some linkers here.
Yeah, take it away, Steve. We've got our original molecule in there just to kind of show us a little bit of a guide of what it could look like. And then we're just going to kind of now, we could iterate on a number of different, molecules bound in here, but we'll just start with this one as an example and look at how we can iterate on linker design now. So we've had a good time looking at the bromo domain binder, and now we'll look at linkers.
Yeah. So this gives us a pretty good idea of what yeah, we could be going for. John, did you just want to hide some of these so we don't end up having the minimization overlapping?
Oh, sure. So right now we're just looking to see how we're able to get a similar vector
Hmm.
to where we might connect to the VHL binder. But yeah, while we design, we'll always want to make sure our pocket is clear, just to make sure we don't have any minimization issues. So I'll just unlock that. You can lock up here, pull it out, and now it's ready for Steve to
Perfect.
take a look at
So
it.
I'm just going to go ahead and yep, take the protein now. So we could see that we have our docked ligand in the pink, and then we have the ligand bound our E3 ligase in the green. And what we want to do is we want to link them, just how that other that other ligand was just linked. We want to design some linkers. So the first step that I'm going to do is I'm going to select our pink ligand and our green ligand, and I'm going to go over to the modify menu, and I'm just going to go ahead and merge them together. We'll name that 6HAX plus BET docked. I'll apply that. So now they're part of the same molecule file. What we're going to do now is go to the advanced menu, and I'm actually going to create several frames. So let's actually, sorry, I meant to do duplicate frame. So let's duplicate this. We'll do maybe 5 different linker designs. And now what we want to do is use the MedChem tool. So we pull that up. We go over to build, and now we're just going to start building a linker. So we're going to go from the pink ligand over. So first we'll try out a PEG linker. So I'll just do another carbon there. Get my oxygen. I'll get another carbon, and we'll just give it some nice room there. Oops, accidentally replaced that. So I will go ahead and put that oxygen back to how it was. Okay, so this is going to be our first one. We could see that the minimization has brought it into an okay state. Maybe there's several different configurations it could take with that sort of flexible linker that we have in there. But I think this one's okay for now. We're going to take our advanced menu and we're just going to go back to our original one. And now let's try some other designs. So maybe on this one, I'll actually add a benzene here. And then let's just go ahead and connect it right there. So yeah, that's going to need some minimization. Yeah, you can see that it kind of wants to flex this benzene ring, which yeah, maybe we want something a little bit less rigid. So John, when we were going through this earlier, had actually recommended instead of a full benzene, that we just use a cyclohexane. So we could see what that would look like as well. And then I'll just create the bond over to that. Kind of pull that, get a lot more flexibility with that because we have these more flexible bond angles as opposed to the double bonded benzene. We'll do a couple more. And this is when I'm just going to get a little bit more exotic here, cycloheptane. Not sure how great of a choice this is. So please on the stream, don't judge me too much at your home or office right now. Just trying to get some variety here.
Let's try
So
branching off. We can also on the next one. We could also maybe even branch off to from a different member of the ring, or we can also connect to different points too. Really endless opportunities for how we might rethink our linker. Yeah.
okay, yeah, let's try that out. So instead of going off of the same position that I keep going off of here, maybe we could just kind of make something else. And let's see what maybe we'll go with a peg again, but this time it'll be a little bit of a different one. So maybe if we do something like, oh, oh, oops, sorry, let me undo that one. Got to undo an energy minimization there.
All right. We're just gonna Just needed to kill the minimization job so we can go back a few steps. Yeah,
Yep,
there
we
we go.
go. Cool. Yep, yeah, the undo button's really great. Yeah, sometimes you might have an overlapping minimization that throws things out of whack, but hey, it's a happy accident. And then we'll go ahead and connect that. Oh, whoops. Sorry, we will delete that. And I will reconnect it because it moved as I was building because it was still minimizing. There we go. Okay, now we'll let it minimize. And of course, you could turn off the auto minimization in the prep menu. So right now I have the auto minimize on, so that means it kind of moves as I'm building, but we could toggle that off if we wanted to not have it move until the very end. So it looks like we have several different linker designs, some better than others. Maybe just to kind of play them through. I don't like that 7-member ring that I made, so
Yeah, but it was
choices were
easy to
made.
draw, easy to try out. You're not married to any changes you make, and what's great is we can also test this immediately. So right now we're doing we were able to use docking before. We could redock, or let's actually try some real-time atom scoring, Steve. We can do
Yeah.
like just a quick snapshot in just a few seconds instead of having to necessarily wait for the whole calculation to finish. This is something I like to do just to give me so like Steve doesn't like his cycloheptane. You know what? Let's see if we can have a empirical reason to agree. I'm just gonna go to real-time scoring. We're gonna go to run, and we just have to select our receptor here, which is our 6HAX. And then we're actually gonna be done with this menu for now. So I'll just move this up to here. And then our ligand is the fused one that Steve kind of set up for us. And we'll just start scoring. And what's great is we can kind of take a look at this and we can see, it's going to take a little bit to calculate, but we're going to be able to kind of take a look at some of these different scores here and look at the different frames and kind of see how these are going. But yeah.
Yeah, and of course, we might after this want to run sort of a full redocking. You're saying of the entire
Absolutely.
structure, and that'll give us better results because we still have the negative 7.5 kilocalories per mole of the original docked ligand over there in the pink, but that doesn't account for all the changes that we've now made with the linker.
Yeah. So we'll just run this again for a second, and there we go. Oh,
Yeah,
seems
well,
like
I
there's a
was thinking
connection
even
issue.
just showing
That's all right.
clashes, because I feel like
Sure.
that might have actually had some impact on what we might be clashing with. And if we're just trying to get like a visual analysis, I think that showing H bonding clashes is a
Yeah,
really
chemical
good check.
interactions.
Mhm.
Yeah, absolutely. Yeah, so we can kind of see we don't have any clashes, thankfully. So that's one of the nice things about minimizing in the pocket is as it minimizes, it will reduce those for you. But it is always a great thing to check to make sure, like especially if you see any weird minimizations or anything like that. But yeah, well, so I think at this point we're happy to take any questions and any other things you guys are interested in. But until I get a few from Kada, I'll kind of set up just the chemical interactions for us to assess. Maybe some interactions we picked up, and yeah, we'll just kind of go from 6HAX to our docked ligand here. Oh, okay. Sounds good. Sounds great.
structures.
So the really there's a really cool thing about it because it is a plugin through the web browser, but it is also it's a URL, and I've had a lot of fun using Nanome, of where I'm able to actually, if you go to the same URL that you have here, Nanome's web browser is like every other web browser, and so you can go to this URL as well on your computer and be able to look at Nanome data tables and use Nanome data tables on your browser, on your desktop as well. And so there's a great way of being able to get this, you know, desktop to VR interaction. You get all these sorts of things, and it also makes it easier to use the data other places as well. So it is a bit of both, and it's what's nice about it is how it makes the data more shareable, makes it more interactable for everyone that you want to be involved.
Sorry, I was muted during the last question, so hopefully that's fixed now. The next question is, can some of the menus and tools be accessed directly through voice commands? Is that something planned for the future? So currently we do support voice commands if you're connected to the computer through PC VR. And we have a limited amount of kind of commands that are available there. Unfortunately, tools are not supported, although menus are supported through voice commands. So that is something that can be done. Next one, John, I'm going to have you take this one, which is what rules or algorithms are we following to test the validity of the ligand binding?
Test the validity of, can you say that last part?
Ligand binding.
So the ligand binding overall, I mean, it's a standard, docking approach. So this is SMINA docking. We have the publication in our GitHub as well as, with our Nanome docs. And so you can check out SMINA docking for yourself. But overall, what it uses to kind of validate and understand the likelihood of the docking is using, a force field to describe the electrostatic interactions and trying to understand which ones would be optimal. Now, one thing you notice is that we took pretty seriously the co-crystal pose because we know that that's very real. And so if we see interactions that are very similar to that it has when we have a crystal structure, we can be more confident in the results that the binding pose that's proposed by SMINA docking is more likely to be real. But at all times, eventually you're going to have to put it in, some kind of assay, whether it's cells or, just a binding assay. But yeah.
Next question is, are the minimization and docking offloaded on a server? What are the specifics of the server side? How many concurrent sessions can happen?
Yeah, so we have kind of the way Nanome's set up is you have two servers, one that manages sort of the collaboration and a lot of the VR aspects, and then the calculations in our plugins occur on our plugin server, and so out in the cloud. And so it kind of depends on your deployment type. So we have Nanome hosted cloud, and we have you can host your own cloud, or you can have your own physical on-premise server. And really, depending on each of those situations, you'll have different access at different amounts, and it really depends on what your needs are. And our team is really good at making sure to make sure that that's it's not an issue whatsoever. It's very customizable.
Have we tried to connect to a molecular dynamics engine through IMD and test some steering experiments?
So I would say it's something of where you can bring results in for something like that with Nanome. So I've done an amount of molecular dynamics calculations, other things like that, and then brought them in to understand what's going on and brought them in with my data. So the web browser, I can bring in slides, PDFs, and other graphs and stuff along with my structural data. And so I would say the answer is I brought in other types of data that are similar. I haven't brought in that exact kind, but be more than happy to, show you how to load those in.
Great. The next question is, what is your position regarding the trend of integrating ChatGPT like machine learning? Yeah, this has definitely been something that we've been
very interested in from the beginning. As I mentioned before, we have had some kind of very basic integrations with voice commands, but this is something very much that we think that AR, VR, mixed reality is the best interface to actually prompt engineer, if you will, with AI, whether that be large language models or different types of models that we interact with. So it's definitely on our roadmap, and it's something that we're very interested in. John, did you have any kind of
And the
other? Yeah, go ahead.
Well, there's the great thing about it too is while we're thinking about it a lot with how you will use Nanome, because Nanome is kind of built to be this hub of interactions and this platform for different approaches. There are already groups that have brought in, AI approaches and other things like that into Nanome. And one great example, we just had a webinar on this, is actually, Cynthia, an AI approach for retrosynthesis from Millipore. And so, really, if you have any chemoinformatic approaches and things like that that are already using, LLMs or the things like that, yeah, feel free to talk with us about how you can either bring that in through maybe a web browser option, or we can talk about how you would build a plugin to put it in more specifically. But yeah, it's something that we've been kind of building towards in some ways and making sure we're compatible, in the near term, but also have big plans for always more to be done in the future. And I'll just show a little bit of the Cynthia integration here in Nanome's data table right here. So here you
Cool.
can see the Cynthia score for a molecule and give you an idea of the difficulty of synthesizing it based off of public data sets as well as precursors you can purchase through a number of different vendors. And so this is just one example of how AI and other approaches are coming into Nanome. But once again, it's we like to make it fit your use. So yeah.
Yeah, John, looks like I'm back after a nice impromptu software update. I'm now on version 54 on the MetaQuest Pro. Not sure
Oh yeah.
why
Still gonna
that
come
got
for me in a
timed.
second.
Yeah. Um,
All right.
but yeah, I was just gonna say that was actually really easy to design some of these PROTACs here. Really just looking at some of the docked compounds, making some linkers, just having that utility of being in virtual reality and seeing these things right in front and having that spatial understanding just makes it so much more intuitive when designing these.
Absolutely.
Steve, did you want to
Yeah.
comment on the AI question?
Yeah. Well, I mean, I think that everybody thinks of AI and VR as like synergizing, and just how we have John here. I think that in the future we're going to be having really agents that could talk with you, that could help you out with your science. Right now it's human powered intelligence, but I think that we're increasingly getting closer and closer to having that be artificial intelligence. And the avatar movement, I think, is something that we do right now very naturally, and the AI programs would have to learn. But really, it's the thought process behind what they're doing. You could have AI generated compounds, AI generated synthesis methods, AI generated docking results, AI generated language to talk to, AI generated changes of your structure when you talk with it. Color chain A to be red instead of blue. So really, I think it's endless in terms of all the possibilities, and what we're seeing with the human to human interaction today, I think is going to be increasingly augmented by machine intelligence in many ways.
Yeah.
The next question asks,
Absolutely.
sometimes it would be interesting to look at a molecule moving. Example, when a Cas9 moves over the hinge region, is it possible to flip between structures or to see them move?
Yeah. So I'll load in one example structure. This is just a small one that I know loads quickly and we won't have much trouble with. So I'll bring that in. Um, Essentially, I'll just kind of hand it over to Steve and he can kind of walk you through it. But yeah, we load in trajectory files to allow you to see the motion of molecules and understand the dynamics and everything. We can definitely cycle through lots of different views and things like that. And so we also really any kind of trajectory, whether you create it, via something like a morph or any sort of interpolation, are also things that are really easy to set up in our frame system.
Yeah, you could change, of course, the speed. So you could go one frame at a time, a little bit faster, a little bit faster still, even faster. And then it really smooths out depending on how many total frames that you have, or you go really fast.
Absolutely.
So that's just up to the users. But in terms of generating these, I'd say that once we design those PROTACs, we might want to actually run some molecular dynamics over a longer period of time on some GPUs, and then to play those back and then analyze how that's all moving. Whether we have a stable configuration there. There's a lot of insights that you can glean after you kind of get your ideation and design work done in virtual reality or mixed reality, as you see here, to then go over and run heavier compute, whether that's more docking, more molecular dynamics, more type of analysis of ways to synthesize it. It's just so much that you could interface with, once you get the ideas flowing in a session like this.
The next question is, could somebody without a headset control what people in XR could see using the data table plugin?
Yeah. So one really cool thing is, so I'm gonna bring up my data table. Oh, well, let's bring up I'll load back in the set of structures from before, or at least some structures. And the really cool thing is, this will just take me a second to prepare. But just like we can use the data table on any browser, including that on like a computer or anything else, we can also, if we set this up, really anybody through the data table is able to kind of go through this. So I'm gonna make using 5CO, one of our classic example files. I'm just gonna make a quick series of molecules here, and I'll use one of our macros just to kind of give me a kind of prep this kind of quickly for me. And so from here, I'm just gonna split off my ligand similar to what Steve was doing earlier and make a short series of molecules. So I'll just make 5 real fast. And I'm just going to I'll do some things that aren't actually good ideas, I'll admit, but they're just to give us some examples of, something that's just different enough for us to see. And, I'll replace this and this. And then finally, I'll just replace my fluorines with nitrogens. So now if I go into data table, normally in Nanome, only the presenter can control things. So I'm going to bring up my plugin. I'm going to bring in the 5-CoA molecules, and I'm going to give the presentation over to Steve. And so if Steve looks above my head, he won't see a crown anymore. But now that I have data table, I can cycle through these molecules without Steve, and I can do analysis on these, and I can pass back and forth this idea of, hey, this is what I'm thinking, this is what I'm seeing, while Steve is in VR and he can share his ideas. And we're really trying to bridge to make sure people can collaborate in a lot of different ways.
And this is just a web browser, right? So it doesn't matter if you're in this particular virtual reality web browser or if you're in a different web browser. It's all web browser based.
Well, and what's great too is with our sketcher that we've added very recently as well, is I can even propose changes outside of being presenter, outside of VR. And this new molecule that just came in is, is the molecule I just built in the data table. So you can both suggest new changes molecularly, you can change the view. The data table really allows for, groups to work together and do things concurrently.
And just to fully answer that question there. So, John did just use the web browser. He did it, through virtual reality, but he could have also done this on his 2D computer and designed a new compound. And then that, for me, appeared in pretty much real time. And so you could have a collaboration between, myself and the immersive hardware, and somebody else simply using the web browser. It doesn't need to be this VR web browser.
Yeah. So I'll just bring in another one. Yeah, you can see just a few seconds between them.
Yeah, it's fantastic. Thanks, John.
Yeah, no problem.
Next question is, are there any plans to have more data analytics or informatics integrations with Nano?
So the great thing is, so this is what's really fun about how Nano's plugin system works right now. So you're going to see auto calc properties right here. So that runs it through our DKit. And that's just how we do it, as an example of what it would look like for you to do it. But we can essentially, with our plugin system, we can change, instead of it asking for, RD kit to provide values, you can redirect it to ask really anything else. And so we have other groups that have their own proprietary, chemical properties. And they, instead of seeing the RD kit values that you guys see here, they see their own, or they've purchased, a software package, and we can integrate with that as well. And that's part of what the Cynthia integration is that it reaches out to a Cynthia server and says, here are my molecules. Tell me what you think about this. And that can really happen, you know, across anything. So we're probably not going to integrate any other specific ones necessarily in the base version that you're seeing. But if you have any that you want to put in, we've made it really easy for you to connect that. So that way, technically, we've already integrated with, just about every single chemoinformatic, kind of approach. It's just a matter of directing Nanome to send the SDF or smile string to that one and then putting it into the data table. And we have documentation on our site about how you can do that yourself.
Great. Next question is, what are your thoughts on the Apple Vision Pro? Any plans?
We're all very
Lots of
excited
thoughts.
about that. I mean, well, I guess
Yeah.
first off, like a lot of people don't realize that the current technology does enable mixed reality. This is our real office that I'm looking at right now. This is Kata really on the computer helping out. It's supposed to be higher resolution. These headsets do a lot of eye tracking. I think that Apple's putting together their own user interface in a really clean, nice, and precise, and I think very easy to use way, where a lot more people are going to be able to pick it up and look at things, use those pinch, type of controls instead of using the hand controllers that I have here. But yeah, like a lot of the features that it offers are currently available to try out, like the mixed reality color pass through, the eye tracking, hand tracking, like all these things are currently on headsets like the MetaQuest Pro. But of course, it's Apple. Apple makes really clean, snappy, nice hardware software combinations. And the fact that it's $3,500 means that it's probably going to be a very high end, very nice experience. Yeah, so and it has the multiple chips, the reality processor as well as their typical like M2 type of processor. So I think that they're doing a lot of smart things, which they can do because they have really from the chip level all the way to like end user experience software and everything in between, the hardware, the optics. So I'm excited. I think they've put it together into a very nice, very compelling package. What do you think?
For me, the next level thing, just because I completely agree on all of that, but also if you guys try to use Nanome, we've often had this rule of like, yeah, we work with Windows, and that's just because Windows has been kind of working with a lot of the other headsets. And now this also opens up a lot of other, Mac interactions and things like that. So it's, to me, like, it's not even just the headset, it's that now Apple overall is just more open to XR experiences. So I don't even know how excited to be yet, but I know I'm excited.
Yeah, you used to be able to run things like the Oculus Developer Kit and on a MacBook, but yeah, now you can't actually run a lot of that. But yeah, what do you think, Martina?
Oh, hello. Yeah, I am just generally curious of how it will work, like from the user interface and like the usability standpoint. I mean, just typically Apple always produce like Apple products are, very intuitive, very different from what is already in the market. So I am personally very curious to see how that will work, how we're gonna be able to interact in VR with molecule. What are the new paradigms that they will introduce
Yeah.
in the field?
I guess the other fun thing is like, right now, like, we're looking at each other through the cameras, but I can't see, I guess, your eyes. And, that's one other difference that Apple has. They have the sort of a two-way pass-through mixed reality where you could see me, but I can't see your eyes. Like, so they have a lot of things like that that are interesting. And I guess that they have a lot of experience kind of testing these things out and making people feel more comfortable with the technology. So yeah, it sounds like they're doing all the right stuff, and they've been in the works for 7, 8 years or more. They've hired the right people in industry like Doug Bowman that are experts in this whole 3D user interaction space. So yeah, I think that it's going to be a great product.
Up next, are there any limitations or constraints we should be aware of when using this plugin?
John, you're muted. The data table plugin in particular is the question, right?
Yeah. So there's a few things with the data table plugin I would mention. Mostly this is also like from an XR standpoint, it would be true regardless. So right now we kind of put in like around 500 molecules into the space. Some data tables that you guys might work with might have thousands and thousands and thousands. I would say on standalone headsets, just because of the general space, I wouldn't put thousands and thousands and thousands of molecules in there. And that's pretty much the main limitation I would see. Other things as far as usability that I wouldn't describe as limitations, but just as things to be aware of is I love large thumbnail, large font size, and being able to know where your columns are. They're all just kind of usability things that kind of make it you'll just need to kind of get used to a little bit. But yeah, the main one is don't necessarily. We also don't work with proteins in the data table, so it's really just more file size concerns that I've been having as I work with it.
Great. Next question: do you plan to use the meta avatar that have full face tracking on the Quest Pro?
Well, so John, maybe we could just show the current meta avatars. Yeah, do you want to kind of talk a little bit and
Yeah, so you can kind of see my mouth moving a bit, and I'm gonna kind of like just kind of keep doing these sorts of things. You'll see there's an amount of like I'm gonna close my eyes for right now, things like that, and just sort of seeing there is some right there, and yeah.
Yeah, so as you can see, we have most of the Meta Avatar API integrated. There's always more improvements I think that you can make, but there's a trade-off with the number of users and the bandwidth associated with that. So with a small number of users like this, you could kind of get full facial. But then if you would have like 20 or more users, you would only want to have maybe partial facially tracked features. So there's
Yeah.
some trade-offs, but I'd say right now it's compelling where it feels very social. Like me and John are talking, interacting. When he talks, I kind of see his mouth move, and there's a lot of consistency here. But yeah, I think that Apple's thing looks cool too, and it's just every manufacturer, Meta, Apple, others are just going to keep getting more and more detailed on the social aspect.
Absolutely.
What are future plans for the data table plugin?
Wow. I'm not going to give too many specifics just because we have a lot of things that we know we want to do, and I don't think we necessarily really have an order at the moment. The one thing that we do greatly enjoy, especially working with people, is as they request things, that's where we often kind of nudge ourselves and kind of move in the direction of. And so a lot of it depends on, what you, the users, say that you guys think is the most important next thing and what you would find useful to use in Nanome. And so mentioning things like we can bring in lots of other, chemoinformatics, talk to us about what software you're using, what software you would like to be able to use in Nano more easily. And, we talk to a lot of these other software companies, and all of us kind of agree when we have customers that say we want it, then we're both willing to work in that direction. But we want to make sure that we're building things that are going to be used and useful. And the best way to do that is to listen to folks like you.
So yeah, provide your feedback. If there's things that you would like in data tables that are not currently there, let us know. You could always reach out, hello@nanome.ai. You could, put it in the chat right now. We're very receptive to looking at all forms of feedback.
Final few questions here. This should be quick. Do you have a preferred VR system? It might be good to show the documentation page where we have that hardware matrix.
We could. I could pull that up.
Oh, you got it?
So
Okay, yeah.
yeah. I'm just gonna go to the nanome.ai webpage. So I'll just type that in. So you go to nanome.ai. You could also just go to nanome.com. It'll redirect you. So I'll put that. And then we have the download page. Yep. I'll share the browser so you could all see it too. So yeah, so these are all the devices we're compatible with. So the MetaQuest 2 and the MetaQuest Pro, I'd say are go-to devices for many people, getting started with virtual reality or mixed reality. The Quest 2, I think, is back down to $300. It was $400. The Quest Pro is $999 right now. So I think that these are really nice devices. The Vive Focus 3 is also another great device. That one also includes a few more business enterprise ready features. The Pico Neo we're also compatible with these. I'd say that people have a lot more mixed feelings about the Pico Neo 3 and 4 devices in general, but I'd say these are the main standalone devices. In terms of the desktop or laptop powered virtual reality experiences, unfortunately, there's no compelling mixed reality like you could see the office around us. You would have to have a device like the Quest Pro. For the most part, the mixed reality devices like HP Reverb G2, you have other devices like the the HTC Vive Pro. Those are all really great virtual reality headsets. And you could go down and look at the hardware page on our website here. You could also see other more high-end devices like the Vario XR3. That one does do PC-powered mixed reality, but it does require quite a beefy system in terms of the GPU capabilities. But then, we're pretty much compatible with all the major devices. Also, big shout out to the Valve Index. Although it's a few years old, I kind of like it because it does a really high refresh rate. So you could run it at like 144 hertz, and it feels just so smooth and amazing. So yeah, each has their trade-offs. G2 is great. Vive Pro is nice, although a bit bulky. The Cosmos is all right. I think they've mostly moved on to the Focus 3 for HTC. That's kind of the newer one. Same with Oculus. They've moved past the Rift S and now they're more on the Quest 2 and Quest Pro. But a lot of people have older devices that we still support.
All right, so the last question we have here is, do you have a plugin developer program where someone could access Nanome features without a license? Well, first off, Nanome is available for free on the app stores for personal use, so you could definitely do that. We actually also do have a plugin developer program. If you go to nanome.ai/stacks, or if you just go to our website and there's a web page specifically for our plugin system called Stacks. And then at the bottom, you can find the email there where you can email us about joining the plugin developer program, which is support@nanome.ai. So definitely check out our website. Feel free to email us. And we'd love to have folks a part of the plugin developer program. So that's pretty much it for the session and the stream today. We'll have more coming up in the future, so we look forward to having you all in future episodes. Thanks so much for joining us today.
Cool. Yeah. Thank you, everyone, for watching the stream today. And thank you, John, for joining us all the way from Chicago. And thank you, Martina, for
Hello.
coming to the office and joining us for this stream today.
Thank you, everyone.
Fantastic.
Yep.
All right. Thank you. Bye.
Yep. And thanks,
Bye.
Kata and Mark, for helping out for the stream as well.